Welcome viewers. Hope this video will help you to know about MO energy level diagram for oxygen. This is the MO energy level diagram for nitrogen. Sigma 1s2 less than sigma star 1s2 less than sigma 2s2 less than sigma star 2s2 less than pi 2px2 is equal to pi 2py2 less than sigma 2pz2. This is the MO energy level diagram for nitrogen molecule. Now we will draw MO energy level diagram for oxygen. This one is the MO energy level diagram for nitrogen. We can convert this MO diagram to oxygen by doing slight changes. You see, here there are 3 electrons, here there are 3 electrons, but in case of oxygen, number of electrons will be 4 in p subshell. Here also number of electrons in p subshell will be 4. These MO orbitals will exchange their position. Pi 2px2 and pi 2py2 will go up and sigma 2pz will come down. And these two antibonding pi star orbitals contain 1 electron each. Now let us do some changes so that it can be converted to MO energy level diagram of oxygen. Here it is written O, here it is written O. Electronic configuration of oxygen is 1s2, 2s2, 2p4. 1s2, 2s2, 2p4, or you can write 1s2, 2s2, 2px2, 2py1, 2pz1. 1s can be written as shown, 2s2, then 2p has 3 d gender orbitals. You see these 4 electrons will occupy these 3 orbitals. px occupied 1 electron, py2 1 electron, pz also contain 1 electron, or each p orbital contains 1 electron, and the 4th electron will be occupied by this px. This is 2p3. It was written in case of nitrogen. Now we will convert it to 2p4. You see this 2px will become 2px2, and here one more electron will be kept, or pairing of electron will take place over here. Here 2px1 will become 2px2. You see 2px2, 2py1, 2pz1, 2px2, 2py1, 2pz1. Now these MO energy levels will exchange their positions. You see this is sigma 1s2, sigma star 1s2 for K cell, or in 1s the bonding molecular orbital is sigma 1s2 and the antibonding molecular orbital is sigma star 1s2. For 2s the bonding molecular orbital is sigma 2s2 and the antibonding molecular orbital is sigma star 2s2. Means this bonding molecular orbital contains 2 electrons, this antibonding molecular orbital contains 2 electrons, and this is sigma 2pz2, and this is pi 2px and pi 2py, and each pi 2px and pi 2py contains 2 electrons each. So there are 4 plus 4, 8 electrons. Now these 3 molecular orbitals contain 6 electrons, or contain 6 electrons. Another 2 electron will be present over here, or will be occupied by these 2 antibonding molecular orbitals. But according to Hund's rule, each d gender orbital contains 1 electron first, then pairing will be started. So you see each d gender orbital contains 1 electron, 1 1, and this is pi 2px2, pi 2py2. Now number of bonding electrons are 10. 2 plus 2 4, plus these 6 electrons, total 10 bonding electrons, and number of anti-bonding electrons are 6. You see 2 plus these 2, 4, and these 2 electrons 6. So anti-bonding electrons will be 6, not 4. So you can add 2 electrons over here. 4 plus 2 becomes 6. 6. Then bond order can be calculated by taking this formula, taking the help of this formula. Bonding electrons minus anti-bonding electrons divided by 2. So bonding electrons are 10, number of anti-bonding electrons 6. 10 minus 6 is equal to 4 by 2 is equal to 2. So bond order is 2, or you can write 2. This is for oxygen. MO energy level diagram for oxygen. Electronic configuration of oxygen molecule from MO energy level diagram. Sigma 1s2 less than sigma star 1s2 less than sigma 2s2 less than sigma star 2s2 less than sigma 2pz2 less than pi 2px2 is equal to pi 2p2 less than pi star 2px1 is equal to pi star 2py1. Thank you.